Hello, I welcome you all to this class. Now, today we are going to solve shear force bending moment diagram problems. That in this problem we have to draw the shear force bending moment as well as the thrust diagram. So the problem is on the screen that a horizontal beam AB of length 4 meter is hinged at A and supported on rollers at B. The beam carries inclined load of 100 Newton, 200 Newton and 300 Newton, inclined at 60 degree, 45 degree and 30 degree to the horizontal. Right. Draw the shear force diagram, bending moment diagram and the thrust diagram. So you can see the beam is shown on the figure. That is, you have one beam is there. Here one beam is there whose length is 4 meter. Okay, that beam name is A and B. So the three loads are acting: 100 Newton, 200 Newton and 300 Newton. These three loads are inclined. So the inclination with the horizontal 60 degree, 45 degree and 30 degrees, right, at the point C, D and E. So these are the distances between these each forces: 1 meter, 1 meter, 1 meter and 1 meter. So if you look at the beam very carefully, you can see at the A, right, at A the beam is hinged and at B the roller support is there. Is it or not? It means that where we have a hinged support is there, that is hinged is there, at that point the horizontal reaction will act. Okay, as the roller support is provided at the beam at the B, so at B we don't have any horizontal supports, right? So at A and B, first we have a vertical supports, that is RA and RB will be vertically up, and at A we have a horizontal support will act, which act towards the left side. Why? Because there is a hinged. So at B we don't have any horizontal reaction, right? So first of all, what we need to do, that we have these three forces which is acting on the beam, that at point C, D and E, these forces are inclined. So we have to resolve them, means horizontal and vertical. So for this force 100 Newton, the inclination with the 60 degree, it means horizontal component will be the 100 cos 60, vertical component is 100 sin 60. Similarly, for this force the horizontal component is 200 cos 45 and the vertical component is 200 sin 45. Similarly, for this 300 Newton of load, the horizontal component will be the 300 cos 30 and vertical is 300 sin 30. That you know in your engineering mechanics, right? So means how we resolve the forces if the forces are inclined. So first of all, what we will do, for simplicity, we will draw this figure again and then resolve these forces. So first you can write here, just hold on. Just wait, let's adjust them. So your solution is here. Let's say this is the solution. Okay, so we have a beam is there. That beam is having length is 4 meter. Okay, so at this point the beam is hinged, right? So because of this hinged, let's say this is like this, right? So the horizontal reaction will act at this, okay, and then we have a vertical reaction at A and as well as at B. Is it or not? Then three forces is acting at a distance of 1 meter. So this is one and this is another 200 and this is the 300, right? So as this is 100, so it's horizontal and vertical component you have to find right now. So first of all, you can write that horizontal, how it goes, that horizontal, its horizontal component will goes towards the left. Why? Because the arrow is down, right? So its horizontal component is like this and the vertical component will be like this. Similarly, for this horizontal component is like this and the vertical component will be like this. For this also the horizontal component, vertical is this one and horizontal is this one, right? So if I say the horizontal component, let's say this is the beam name is A here and this is the B, right? So the vertical reaction at A is nothing but the RA and the vertical reaction at B is nothing but the RB, right? So as at A you have a hinged support is there, right? So because of the hinged support, there the horizontal reaction will act at a. That horizontal reaction, let's say it is the HA, right? We don't have any horizontal reaction at B. Why? Because at B the roller support is given in the question, right? There is a roller is there. So but at A we have a hinged, right? So because of this hinged, the horizontal reaction will act, right? Now so what we need to do, we have to draw the SF diagram and BMD diagrams, right? So before, for shear force diagram, we need to know the reaction at A and B. That means the vertical reaction at A and B. And for thrust diagram, we need to know the horizontal. The thrust diagram is also known as the axial diagram, that axial force diagram. So first of all, what we should do, that we need to find out the RA and RB. So for finding the RA and RB, we need to take the moment, right? So for that moment, we should know the vertical forces at C, D and E. So let's say this is C, this is your D, and this is the E, right? So these are the distance, these are apart at a distance of 1 meter. This is also at a distance of 1 meter. This is also at a distance of 1 meter, and this is also at a distance of 1 meter. Is it or not? Now, so what we should do, that we need to find out this horizontal component. Its horizontal component is what here? The horizontal component is simply, you can say 100 cos 45, right? And its vertical component is 100 cos sin 45, sin 60, 200 cos 45, 200 sin 45, and then 300 cos 30 and 300 sin 30. So here we can write first the first of all, you can say the inclined load at C, this you can make here, the inclined load at C is having, not C, at C horizontal component is horizontal component, right? So horizontal component of a inclined load at C is what? That is nothing but, let's say this is the WCH, and it is what? W is nothing but 100, so that is 100 cos 60 degree, right? So this value will come as 50 Newton, right? Similarly, the vertical component at C is what? The vertical component at C, right? So W CV, H is for horizontal and V is for vertical. It is nothing but the 100 sin 60 degree, right? So 100 sin 60 is nothing but, you have a 86.6 Newton. So these data we calculated, means we have resolved the forces at C horizontally and vertical. So horizontal force we got 50 and the vertical is 86.6, right? Now, so now what you need to do, you can write this data, these values. So here you have this horizontal forces 50 Newton you got, and the vertical is how much? Vertical is 86.6, right? Similarly, we can find the horizontal and vertical component at D. So horizontal component is what? 200 cos 45 and vertical is 200 sin 30. So directly we can write so directly we can write that horizontal component at D is what? That WDH is equal to 200 is given, so it is 200 cos 45, right? So 200 cos 45 means what? That it is 141.4 Newton, right? And the vertical component at D is WDV is equal to 200 sin 45, right? So its value is also, yes, 45 is having same, so that is 141.4 Newton, right? Now we have one more force at a E, right, whose magnitude is 300 and the inclination with the horizontal is 30 degrees. So similarly you can say the horizontal component at E is, that is, sorry, this is C, WCH, right? So WDH, very good, WDH only, I'm very sorry. So this is horizontal component at E is what? WEH is equal to 300 cos 30 degree, right? And the values will be 260 right, 260 Newton, and the vertical component at E is nothing but the WEV is equal to 300 sine 30, which values is 150 Newton. So all the horizontal and vertical forces we got at the point C, D and E, which is given inclined force in your questions, right? So first we resolve them. Now what we need to do, we have to find out the reaction at A and B, that is vertical reaction. So as well as we have to find out the horizontal reaction. So if you look at the figure, that if you look at this, is it or not? So at A, because of that hinged support, the horizontal reaction is acting, and the horizontal reaction is acting towards left side. It means that the horizontal reaction at A is nothing but the algebraic sum of all the horizontal forces at C, D and E, right? Why? Because this horizontal is acting this side and this will be. So balance is means what? The right side forces should be equal to the left side forces. So now you can do that. So you can write here that it's better. We can say that let HA is the horizontal reaction at A, right? And this HA is equal to what? This HA means horizontal reaction at A is nothing but the sum of all horizontal component of inclined load. So you can say sum of all. Why? Because why I am writing, it's not required, right? If I am writing and then if you make a notes, then at the time of revision it will be easy to you, right? So sum of all horizontal component of inclined load, right? Component of inclined load. See, the main purpose of writing all these statements is that so you will means when you watch the videos you can make a proper notes, right? And then next time you just go through with the notes, right? If you have a lot, means then also you have a confusion, then you second time you can watch the note, means you can save the time, right, by making the note at the time of watching the videos right now. So that will be save your means time and everything. So here you can say the HA is equal to what? Sum of all horizontal component of inclined load. That means if you look at this again, so how many horizontal load is there? That is this and this. So these values we have not written, I think. So these values you can write, right? So its value is 141.4 and this is also 141.4, that we forgot actually. So horizontal component for this 260 and this is the 130, right? Now so here HA is equal to what? That you can say HA is equal to sum of all horizontal forces. So all horizontal forces is 50 plus 141.4 and plus 260, right? So this HA we got, HA is equal to how much? 451.4 Newton. So this horizontal reaction at A we got, which is the 451.4 Newton, right? Now what we need to do, we need to find out the vertical reaction, that is RA and RB we have to find. So for finding, if you look at the RA and RB is acting in the upward, and these three vertical forces which is at C, D and E is acting vertically downward. Means what? That again you have to equate the equilibrium condition. So you can say that RA plus RB is equal to what? If you remember that RA plus RB is equal to, look at this RA is acting upward, RB is also acting upward. So these two forces are balanced by the sum of these three vertical forces, means 86.6 plus 141.4 plus 130. So you can write it here that RA plus RB is equal to 86.6 plus 141.4 plus 150, right? So this equation will become RA plus RB is equal to 378, right? Let's say this is equation 1, right? Now to get this, to simplify this equation, we need to take the moment about A. So moment is what? Moment is nothing but the force into perpendicular distance. So as I have assumed that I am taking the moment about A, so you can take the moment about B also, there is no problem, right? So as I take the moment about A, so at the A means how many forces? This vertical force, this vertical force, this vertical force, and this reaction. So this means if I take the vertical component at the C, so horizontal distance is what? 1. For this vertical component at D, the horizontal distance is 1 plus 1, 2. For this it is 1 plus 1 plus 1, that is 3. So RB is what? This. So if you look at this, the moment is of two types, that clockwise and anti-clockwise. So because of these three forces, these vertical downward forces, you'll get the moment as a clockwise, and because of this vertical reaction from this side, you'll get the moment as a anti-clockwise. Means the clockwise will be one side and anti-clockwise will be another side. Okay now so we can do it here directly. I can write that here, write down that taking moment about A, right? So when you take the moment about A, so what you get, that will get the RB into the total distance is 4 is equal to the vertical component into distance at C. The vertical component at C is nothing but the 86.6 and the distance is 1, plus the vertical component at D, that is the 141.4, right, into the distance from A to 141.4 is what? 2 meter. Again one more force is there, that is vertical component at E is 150, right, into 3. Force into perpendicular distance, force into perpendicular. As you are taking the moment about A, so at A reaction is there, but there is no distance, so that's why we can't take the RA, right? So now you simplify, means you simplify this value, you'll get the RB value. So directly I'm writing the RB is equal to 204.85. This one reaction we got, that at B we got the reaction, this is 204.85 Newton. This reaction value, when you substitute into this equation, in the equation 1, you'll get the RA. So RA is equal to what? 378 minus RB. So directly that will get the RA is equal to 173.15 Newton. So these two reaction we got. It means that we got the horizontal reaction, vertical reaction at A and B also. Now simply we need to draw the SF and BMD diagram. So SF diagram is what? The shear force diagram is nothing but the algebraic sum of all the forces acting on the beam, either on left or on the right. Right now, so this is what you have a shear force diagram and bending moment diagram. So first of all, this paper I'll take. Yes, see, shear force diagram we have to take. So you can start calculating shear force either from A or from the B. There is no restriction. It is up to you. So your wish. Either you can start from the A side or from the B side. So as I hope, means you know the shear force and bending moment diagram sign conventions. Right now, so if you start from the A, so left side upward will be positive and the right side downward will be negative. If you start from this, so left side upward will be negative and right side downward will be positive. So as I am starting from the A, right, so if you see this, so at A is what is the vertical force? RA. So whatever the magnitude of RA, that is your shear force at A. Similarly, between A to C we don't have any forces, so between A to C the shear force will be constant. But again when I reach to the C, there is a vertical load is acting which is downward, so this load we should subtract from RA to get the shear force exactly at C. Again between C to D we don't have any forces, it means the shear force remain constant. But when you be reach to the D, there is a vertical downward force will act. It means again we have to subtract this value from the whatever the calculated value is there, right? Again from D to E we don't have any other forces. It means that the shear force remain constant between D to E. But when you reach exactly at the E, there is a vertical downward forces is acting. Then we have to subtract these vertical downward forces from this whatever the value we have, and then shear force is remain constant, and at B this you have to add. Okay, so now first of all we will write down the shear force diagram values right now. So now see here, we can say that SFD, right? SFD means shear force diagram. So first of all we will say the shear force at A, right? Shear force at A. Shear force we are saying F. So F suffix A means that is what? Plus RA. Means it is your right side, right? So left side upward will be positive. And what is the RA value you got? RA value is nothing but 173.15. Just now we have calculated 173.15. This is Newton, right? I'll show you again, as I told you just now, that if you look at here from A to C, just before C, we don't have any forces is there right now. As you don't have any forces is there, so the shear force will be remain constant, right? So between A to C, but when you reaches to the C, then that force will be subtracted. So now next statement we can say the shear force at A is this one, right? That is plus 173.15. Then you can say the shear force remains constant between A to C. Why? Because no forces is between A to C. So that constant means what? It will be same, that that is equal to plus 173.15 Newton, right? But now we have to find out the shear force exactly at C. So exactly at C means what? That when you reaches to the C, there is a vertical downward forces is acting. So it is still you are, as you have started the calculation from the left side, so till here you are supposed to be in the left only. It's not like that you are going towards the right. You still end of the beam, you are in the left only, as you have started from the left. So at the C, the vertical forces is acting, so left side downward is the negative. So it means that this load you have to subtract from the calculated value. So calculated value till now is what? 173.15. so now you can say the shear force at C, right? And FC is equal to what? This is 173.15 minus 50. Why? Because it's your 186.6, I think so, 86.6, I'm sorry, that is 86.6. so when you calculate this value, you'll get the FC is equal to it is 86.55, right? You can cross check the values, 86.55. It means that now because of this vertical downward forces, it takes time, right? Don't worry. So at the C, this vertical downward forces is acting, so we have subtracted. Now the shear force value is become 86.55 Newton. Now again if you look at that as you are moving from C to D, there is no other forces. So between C to D you have a shear force is remain constant, but at D this force will be subtracted. For again D to E there is no forces, it will be constant, and E it will be subtracted, and so on. So right now, so now I'll directly write that shear force remains constant between C and between C to D, right? And that value is what? That value is nothing but the 86.55 Newton. Now you need to find out the shear force at D, as you have reaches to the D. So shear force at D, right? So FD is equal to what? FD is equal to 86.55, and you can see the vertical downward forces at D is what? 141.4, right? So this value you have to remove, I mean subtract. Why? Because it is your left, and left side downward is negative. So this from this value 141 point subtracted. So FD at is equal to what? This minus 141.4, right? So the your answer is 54.85, and this value will come in the negative. It means that it's come down right now. Now again between D to E no other forces, so it will be remain constant, and this. So you can say the further the shear force remains constant between D to E, right? And what is the value? That magnitude is still minus 54.85 Newton. This is Newton, right? Now, so again you have a at E you have a one more force is there, that at E if you look at the 130 Newton vertically downward, it means that this will be subtracted from minus 54, right? So you can say shear force at E is that is shear force at E means Fe is equal to minus 54.885 minus that value is 130, right? So this is 130. So when you simplify this, you'll find the value will be 204.85. This is the 54 point, sorry, this is 150. This is the 150 right now. Yes, so this is 150. So it is what? 204.85 Newton. So if you look at that, the shear force at the end E will be same as like a reaction. Why? Because you can see the beam. That shear force at E we got 204.85 and the reaction value at B is also same. Means this and this value should be same. It means the calculation will be same. Why? Because there is no other forces. So this force should remain constant till here. Right, when you move to this side, the shear force will be 0 because there is no load and no beam section in there right now. So make a correction, there is a little mistake. This is not 130, this is the 150, right? Okay, now so shear force at E we got, that is 204.85. Now we need to find out the bending moment diagram. Right now that this value we have got, from these values we will draw the SFD diagram at the end of the questions. Now we can say the BMD, right? So here only, that's your next you are going to find out the BMD, that is bending moment diagram. Always remember the bending moment at the end of the beam will be 0 if it is simply supported, right? In cantilever beam, the bending moment will be 0 at the free end, but at the fixed end the bending moment will not be 0. But in case of the simply supported, this is the case of the simply supported. Why? Because the two supports are there at the two ends. So at the two ends means at A and B the moment will be 0. So first we can start calculation from the A's, right? So we can say the bending moment at A is equal to bending moment at A. So this is what? MA is equal to 0. As I told you that moment at the end will be 0. Now we have to find out the bending moment at B, right? So I'll show you that moment calculation, you know. This is your, bending moment at C we are finding. So what are the moment at C? This vertical forces is acting, you are finding about this. So moment is what? Force into perpendicular distance. If you take this force RA, so perpendicular distance is what? 1 about C. So if you see then how the beam has bended. So let's say this is your C point right now and this is your force, or it's better you can say let's say this is your, just wait. So this is your force, the finger is RA, right? And this is the C where I'm keeping this finger right now. So how it is rotated? It will be rotated like this, is it or not? It means that this is your left hand, okay? And if the beam is bended from the left side clockwise, right, it will be positive, okay? So now we can say the bending moment at E is what? The bending moment at E is nothing but the force into, C is equal to force into perpendicular distance. Just hold on. So we can say the bending moment at C, that is MC, is equal to what? RA into 1. And RA value is what? That RA is nothing but how much? 173.15 into 1. Same value will come, that is 173.15 Newton meter. So bending moment at C we got. Now we'll move to the bending moment. We'll calculate the bending moment at the D, right? So here itself, just wait. We can say the bending moment at D, right? So at D you have a two forces will be included. If you look at, that means what? The moment because of this reaction as well as the moment because of this vertical component at C. So it means what? If you take this force, so this force is like vertically up, it means that because of this load the moment will be clockwise, that is RA into this total distance 2 meter, but because of this the moment will be the reverse, anti-clockwise. So it is what? Means vertical component of C into 1. So this will be positive and this will be negative. Why? Because from the left side, if the beam is bended clockwise, it will be positive, and it anti-clockwise it will be negative. So now you can say the bending moment at D, right? So bending moment at D is equal to, that is MD is equal to here RA into 2 minus WCV into 1. WCV is nothing but the vertical component at this. So just for understanding, I am writing this equation right now. In next step we won't write, so you need to be understood. That's why I am telling that write down the notes, right? And then it will be better for you. So RA is what? 173.15 into 2, right, minus vertical component at C we have a 86.6 into 1. So we have a vertical bending moment at D we got, that is 259.7 Newton meter, right? Now we need to find bending moment at E. So you can write that bending moment at E, right? BM at E. So bending moment at E means what? That we can say ME. So if you look at that at E, we have a three forces are included. That is what? This at this point we are finding the moment. So this RA into this total distance means 1, 1, 2, 3, and this vertical component at C plus vertical component at D means these two are negative, right? And this will be positive. So we can say here that bending moment at E is equal to what? I'll write on this. That is RA into 3 minus WCV into 2 minus and WDV into 1, right? So those value you can substitute. This is RA is 173.15 into 3 minus vertical component at C is 86.6 into 2 minus vertical component at D is 141.4 into 1. So we'll get these values. How much? It will be 204.85 Newton meter, right? So bending moment at E we got. Now we have to find out the bending moment at B. As I told you at the beginning itself, that moment at the end in the simply supported beam will be 0. As you have taken bending moment at A is 0, so bending moment at B is also 0. Now finally you can write that bending moment at B. Okay, so what is the magnitude? That MB is equal to 0. Alright, now all the moment we got, shear force we got. Now we have to find out the thrust diagram, or we can say the axial force diagram, right? So for axial force diagram means what? That you need to find out the axial force. Axial force means what? Along the axis. So along the axis in the sense that horizontal forces you have to take, right? So if you say the axial force at A is what? The axial force at A is nothing but the horizontal reaction at A. Axial force at C is what? That horizontal reaction plus this, but this means sum at C. Again this is what? At D, this means HA minus 50 minus 141.4, right now. So like this will go. So we can say the next you have a, here you can make a note that will be better for you, that thrust is nothing but the force, right? Thrust diagram or axial force diagram, right? Axial force diagram, right? So the thrust force diagram, you can make a point that thrust diagram is due to horizontal component, right? Horizontal component, right now, horizontal component, including the horizontal reaction, right? So first of all, you'll find out the horizontal means axial forces at A, C, D, E. Okay now so let's do that. Here, just wait. So now you can write that axial force at A. Just wait. So this is what you can say: axial force at A is equal to what? That is horizontal reaction. It is means I'll show you. This is your beam, and the horizontal reaction is going towards the right. So right side force will be positive, means HA is going right, so it is positive. This is negative, this is negative, this is negative. Now, so horizontal force at A is nothing but you have a horizontal reaction which is plus HA, and it is equal to how much? You got already? We got now. Horizontal reaction is, we calculated, let me check with. Yes, that is horizontal reaction is 451.4 Newton, right? At the starting itself we have calculated this calculation. So this is the plus 451.2. That sign convention is very important, will play a very vital role right now. So now axial force, if you see, then same things, that axial force between A to C is remain constant, but C we have a horizontal force is there, so C is what? HA minus 50. Similarly between C to D constant, at D it is whatever calculated value minus 141. Similarly D to E it is constant, at E minus. Is it or not? So that need not to write that much of a statement. Directly I am writing the axial force at C, D and E, right? So next we can say the axial force at C, right now. So that is equal to, you can say 451.2 because of horizontal reaction, minus at C the load is there whose value is 50, right? So this value will come as 401.2 Newton. Again this will be constant between C to D, and now we need to find out the axial force at where? At D, right? And that value is 410.2 minus that horizontal force, that is 141. So it is 401.2 minus 141.4, which is 259.8 Newton, right? Again this D, between D to E this force will be constant horizontally. At E there is a horizontal force is acting, which is having magnitude is 260. So we can say axial force at E. What is that? That axial force at E is nothing but 259.8 minus that 260 you got. Is it or not? 260. That is near about, it will be 0 only, right? That is 0 Newton. Actually this value is 259.8. This is also 259.8, is something about what is called 260 or 0.2 Newton load is not make any impact right now. So all the forces means shear force we got, bending moment we got, as well as the axial thrust we got, means axial force we got. Now it's time to draw the SF BMD diagram right now. So very carefully you'll see. Just give me more 2-3 minutes. We have finished the questions, right? Now, so whatever the question is given to you, that this question I'm talking about, this one, actually this is your problem. This beam is given in the problem, so we have simplified this. So we'll do one thing, we'll draw both the figures, and then below that we will draw the SF and BMD diagram right now. So very quickly we'll execute this. So let's say this is your beam, this is your problem, this is the reaction at A and B, right? So let's say this is your hinged and this is your roller, right? So these are the reaction and this is your reaction, right? So now this is the A, B, C, D and E, right? Now, so at this point load is given and the inclined load and inclined load. This is 60 degree, 45 and 30, right? So its magnitude is 100 Newton, 200 Newton and this is the 300 Newton. All right, now then we have simplified this equation, this beam, as in this manner. So this is what you have, a reaction RA and this reaction is RB. This is the horizontal reaction, is it or not? So let's say this is the horizontal reaction is HA, this is the vertical reaction is RA and this is the vertical reaction is RB. All right, now so as you have this inclined force is given, so we'll get their component, that is horizontal, okay, horizontal and vertical. So I'll show you that this is your vertical and this is horizontal, this is also vertical, this is horizontal, this is vertical and this is a horizontal. Value I am not writing, just you remember C, D and E. So this distance is 1 meter, this is also 1, this is also 1 and this is also 1. In your exam, what you need to do, that you'll use the scale and pencil, that will be better. Here I am using the sketch, right, and I'm not measuring with the pencil scale. So but in exam you need to measure, means use the scale. So what you need to, that the reaction is given, so below the reaction we will draw one straight line, right, and here also we will draw the straight line, right, and wherever the load is given from this point we need to draw the dotted line, right, that is the broken line wherever the load is given in between this reaction, right. So first I will draw the shear force diagram. So this is your horizontal line. So now we need to take the values. That shear force at A is what? That shear force at A is nothing but the reaction, means 173.15, it is positive. So positive you need to take above and negative you need to take below. So anywhere you can take, let's say I am taking 173.15 is this right now. So this is your, and then between A to C it is remain constant, okay, but exactly at C the shear force value is become how much? That shear force value is become at C is 86.55. so this will be, this is coming down, that is 86.55. this is the C because of this vertical component load, right. Now again it is remain constant between C to D, and exactly at D it's become negative, sorry, at D it is 54.85, right. So at D it is this, right, so it is 54.85. again shear force at D is 54, yes, minus 54.85. so minus 54 means what? It will be come down and remain if it is constant between that's why this is D and E right now. So these are the little mistake which we can execute. So now at E the shear force is become what is that? Shear force is remain constant between E to B, and the shear force at B is, this is the 204.85, right. So this is your 204.85. so it will be added by this much and then this is like this, right. So now this is the positive, so you can say this, the above is positive and below is the negative, right. Now you can mention the name A, B, C, D and E. So this value we can write later on. Now we need to draw the BMD, that is bending moment diagram. So at the end bending moment is 0. Let's say bending moment at A and bending moment at B is 0. So bending moment at C is what? 173.15. This is here somewhere we can take, right? And bending moment at D is 259. So as this is C 173, so 259 will be more than that. It means it will be some here, right? Then again bending moment at E is what? 204. It means that bending moment at E should be between this and this point. So it will be here, and A it is 0, B it is 0. So see that while you finding the bending moment, you just multiply the force into distance. That means that distance power 1, right? So it is the linear equation, means the straight line equation will get. So while you draw the bending moment diagram, in that case it will be a straight line, right? Then it will be like this, then it will be like this, and finally it will be like this, right? If it is the distance squared, then the curve will be the inverted parabola that we will see in case of the UDL problems. So this is your A, B, C, D and E. Now we need to draw the thrust diagram. So for a thrust diagram we have to extend this line further as per the requirement. So these are the whole load, right? So this is your thrust diagram, right? So thrust at A is what? The thrust at A is nothing but the horizontal force is 451.2. let's say it is here, and it is remain constant, right? And at C it become 401.2. so it will be here, means 50 we have to subtract, so we have removed the 50 and this will be 451.2, and it is remain constant till D. Again at D it become 259.2. so this is the 259.2. again it will be like this, right? So this is 259.2 and it is remain constant, and then at E it become 0, right? So it will become 0 and it is like this right now. So now this is A and B, C, D, E. We don't have any horizontal force at B. So this value is 451.2. So you can write it here from this pencil, that is 451.2. This is 50. Why? Because you have subtracted the 50 at C, and then this is the 250, 401.2. So this is what you have, this is 141.2, right? So this is 141.4, and this is how much? 259.8, right? This is 259.8. all right. Now then bending moment at A and B is 0. Bending moment at C is how much? Bending moment at C is 173.15. this is 259.7 and this is 204.8, right? And this is positive. Its value, shear force at C is 173.15, right? And this much value you have subtracted. So shear force at C we got actually 86.5. So this is 86.55. So this value is 86.6. Again this much value you have subtracted. So this is what you got the shear force here. It is minus 54.85. As you have written downward, so need not to write any negative values, right? And further it is the 204.85 right now. So this is how we can draw the shear force and bending moment diagram of a given questions, right? So this is all about the today class. Thank you.